Section 1.3, average rate of change. Average rate of change. Definition. We say the average rate of change of y with respect to x as x changes from x1 to x2 is given by y2 minus y1 over x2 minus x1, provided x1 cannot equal x2. So if we have a function y equal f of x, y1 would be f of x1, y2 is f of x2. Then the average rate of change equals y2 is f of x2 minus y1 over x2 minus x1. For example, if we let f of x be x squared plus 5, we need to find the average rate of change. As x changes from 1 to 4. So the formula for the average rate of change is given right on this page. This one, that's called x1. This is x2. So we need to find f of x2 minus f of x1 over x2 minus x1. Means f of 4 minus f of 1 over 4 minus 1. So remember, f of x is given here as x squared plus 4. If we would like to find f of 4, that would be 4 squared plus 5, 21. F of 1, that would be 1 squared plus 5, 21 minus 6 over 3, 15 over 3. Any questions about this?
No. No.
So we can move on and explain or show you on the graph what does that mean.
Yeah, can you graph it,
So
please?
if we have any function like this, f, and we pick a point here on the graph, this is x1, f of x1. We pick another point here, x2, f of x2. This line, we call it the secant line, the line connecting these 2 points. Notice this is x2, this is x1. So this is x2 minus x1. This is f of x2. This is f of x1. So this distance from here to here, it's f of x2 minus f of x1. What's the slope of the line? We know it's rise over run. The rise is the green distance, which is f of x2 minus f of x1. And the run is the blue horizontal distance, x2 minus x1. That's where that came from. This is simply the slope of the secant line. Okay, so now sometimes some people can look at it in a different way. I'm going to take the same graph of the function f, and you pick a point here, x f of x. If you move an h distance from x, so that becomes x plus h, watch what's going to happen. This is f of x plus h. So this is the secant line. If you draw a horizontal line like this vertical distance, the rise, is f of x plus h minus f of x, because this is f of x. And the horizontal distance is simply h. So if I want to find the slope of the secant line, it's f of x plus h minus f of x all over the run h. This is called difference quotient. Okay, so let's look at an example. Find the difference quotient for the function f of x equals 3x squared plus 1. The way I always do it, I first write it down, f of x plus h minus f of x. That's the formula for the difference quotient. One thing to keep in mind, I always put a parenthesis around this function. It helps a lot. F of x plus h, what is f of x plus h? If you want to find it here on the side, you replace x with x plus h. Equals 3 times. This is x squared plus 2xh plus h squared. Where did I get that from? I'll show you in a minute. Multiply by 3. So that goes for f of x plus h. 3x squared, 6xh, 3h squared plus 1 minus, don't forget the parentheses, the function itself, over h. Notice, where did I get that from? When I expanded, there's a formula, the a plus b squared. A squared 2 times a times b plus b squared. Then we multiply, keep this the same for now. Multiply the negative 1, there's a negative 1 here, minus 3x squared, negative 1 by 1, minus 1, all over h. Notice 3x squared cancels, 1 minus 1 cancels. On the top we can factor an h out, 6x plus 3h, all over h. This cancels this, that gives us 6x plus 3h. For the same problem, we need to find the difference quotient if x is 5 and h is 2. What do? We don't have to do it again. We just take the answer and try to find what that is. Evaluate that answer we just got, which is 6x plus 3h. 6 times 5 plus 3 times 2. 30 plus 6, 36. What about if I keep x the same, but I make h smaller? Say h equals 0.1. Try to find what that is going to give us. Same thing, if x is 5 and h is, let's make it way smaller, like that. What would be the difference quotient value? These values are given, x equals 5 and h equals whatever the number is. So 6 times 5 for x, 3 times 0.1. That's 30 plus 0.3. So that gives me 30.3. For the next one, 6 times 5 plus 3 times 0.0001. That's 30 plus 0.0003. So the answer is 30.0003. What's happening here? I'm fixing x at 5. And I'm changing h. I'm making h smaller and smaller. Smaller means closer to 0. So the first one was 2, the next one 0.1, the next one 0.0001. So as h gets closer and closer to 0, the value of the difference quotient is getting closer and closer to what? To 30, right? Do you see the values, the circled numbers? Find, again, the difference quotient for the first function, 2x squared minus 3x plus 5, and the other function, f of x, is 1 over x. Let's go over the first one. F of x plus h minus f of x over h. That's what we're going to find. Don't forget there's a parentheses here. So there's a minus parentheses, which is the function itself. 2x squared minus 3x plus 5. Now for f of x plus h, if you like to find it on the side, you replace every x with x plus h. square minus 3 times x plus h plus 5. And what do we get from this? This is x squared plus 2xh plus h squared minus 3x minus 3h plus 5. Then multiply the 2 in. Keep this the same, keep this the same, plus 5. So this goes here, 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5 minus this whole thing over h. And now we just have to simplify. This stays the same, same, same. Multiply by negative, all over h. 2x squared minus 2x squared cancel. Minus 3x, 3x cancel. 5 minus 5 cancel. I can always factor h out from the numerator. 4x plus 2h minus 3 all over h. These cancel out. So that gives me 4x plus 2h minus 3. That's for the first one. For the second one, f of x plus h minus f of x all over h. F of x plus h, I replace x with x plus h minus the function itself over h. Now, how do we simplify these kind of fractions? Those are called complex fractions. We look at all the denominators, this, and this. The LCD, their LCD is x times x plus h. So what we are going to do here is multiply the numerator of each fraction by the LCD. So you multiply here by x times x plus h, this by x times x plus h, this by x times x plus h. Notice how x plus h cancel. So that will leave x minus x will cancel. 1 times x plus h. Always keep the denominator the same, never expand it. Is it done simplifying? The answer is no. On the top, we can clean up the parentheses. X minus h. It's minus h. Since you distribute the negative 1 in. and that will leave negative h over hx times x plus h. Now the h cancel each other. That will give us negative 1 over x times x plus h. That's what we got. Any questions about this? Okay, how do we find the LCD? That's a question. Um, if we go back to algebra and we have, let's say, 1 over x plus 2 over x plus 3, what would be the LCD? The least common denominator would be simply their product, x times x plus 3. If we have 3 over x minus 1 over x plus 2, again, the LCD is simply their product, x minus 1, x plus 2. That's how we find LCDs. Other questions?